Hello everyone, today we are going to solve GFG problem of the day. Subarray with sum k, here expected time and space complexity of big of n, both. So we'll be doing in those constants only. So let's see what the problem says. So we have been given an array and k. So what we have to do, we have to find all the subarrays whose sum is k. So subarray means the contiguous part of the array. So if we start from 10, we have many subarrays, only 10, 10 to 10 to minus 2, 10 to minus 20, 10 to 10. This is if starting from 10, then is starting from 2, only 2, 2 minus 2, 2 minus 20, 2 minus 20, 2 minus 2 minus 20, 10. So these are starting from 2 and so on. Like this, so on. Okay, so we have to find all the subarrays whose sum is minus 10. So let's see here how many subarrays we have. So if you see, this is one subarray whose sum is minus 20. If is starting from 10 and here, so 2 minus 2 is 0 and 10 minus 20 is minus 10. So one subarray, this is one subarray. If you see 2 minus 2 0 and minus 20 plus 10 is minus 10. And there is another one is this minus 20 and 10 only if we consider minus 20 plus 10 is minus 20. So there are three subarrays whose sum is minus 10. So we need to return the count. So there are three, so we can return 3 and that would work. So what the first approach that comes to mind is find all the subarrays and check the sum, and if the sum equals to minus 10, that is a possible answer. So finding all the subarrays would take n square time, and if we are assuming that we are doing prefix sum and not doing anything for sum, then it would take n square time complexity, no extra space, but you know that is not the expected from us. We have to do it big of n. So it's a brute force approach, but let's try to optimize it. So another approach that comes to mind is sliding window technique, but sliding window will fail because there are negative, and in sliding window what we assume is we will increase the window size, then we will decrease the window size. So first let's say we have increased our window size, let's say till here. Okay, now I want to decrease my window size. So let's say my window size is minus 22 and I want to decrease it. Minus 20, minus 22 minus minus 2. Okay. So I want to remove this 2 from my window. So I will decrease that. But if I want to decrease it, minus 22 minus minus 2, that is minus 22 plus 2. That is increasing my window size. So that is not a expected approach. Let's dry run one case with negatives and let's see how it is creating problem and not giving us the solution. So here k is equals to 3. So if we see, let's find all the subarrays whose sum is minus equals to 3. So if you see, this is one subarray whose sum is minus 3. This is one subarray whose sum is minus 3, and this is one subarray whose sum is, so I'm really sorry, whose sum is 3. So these are all the subarrays whose sum is 3, but let's try it from sliding window. So sliding window, what we do is we will keep increasing our window size until we are lesser than 3, and when we are greater than 3, we will decrease, and if we are equal to 3, that we will count in our answer. So let me store the sum. So currently my window is at 1, so only this sum is 1. Again I will increase my window size because my sum is lesser than 3. So now my window sum is 0. Again I will in because my sum is lesser than 3, so I will keep moving ahead. Now my sum is now 5. So as soon as my sum becomes 5, I will start decreasing my window size. So now I will remove this 1 from my window, and 5 minus 1, that would be 4, that would be stored in my sum. That's perfectly fine. Now I came here and I will see my sum is 4, that is greater than 3, so I will try to reduce my sum. And 4 minus minus 1, if you see, that would be increasing my window size, that is becoming 4 plus 1. So that will not work because we are assuming we are decreasing, but due to negative, it's increasing window sum. But let's say, oh, let's see. So now my sum is 5 and my window is only this one. Still 5 is greater than 3. I want to reduce it more. So I will decrease this 5 from my window. 5 minus 5, 0. Now my window sum is 0 and my window is like there is nothing. If this 2 minus 2 comes in my window, I will store minus 2. I will see my sum is lesser than 3. So I will increase my window. Minus 2 plus 3, that is 1. So 1. And if you see, my window size is still smaller than 3. We have reached till the end, but we didn't got any solution. But we can see there is this, there is this. So these solutions we missed. We missed because of negative. So we cannot use sliding window. So let's see what approach we can use. So let's take another example. Here let's assume k is equals to 3 again. So now if you see, let's say till this point, the sum is x, and till this point, let's say the sum is x plus k. Okay. So between those points, till here sum is x plus k. So if you x plus k minus x, that would give me k. So if you can find that till here the sum is x plus k, and somewhere below, like somewhere earlier we got a sum x, that means till here this sum is k. So this approach we will be using it, and for this what we need is, we will be storing all the sums till now, and if we find anywhere sum is earlier, we got sum like till here, if we got the sum x plus k, so we will try to find out, is there any point we got sum x. If there is any point we got sum x, that means from here to this point the sum is k. So that approach we will be using. So we will be storing all the sums. So let's see. So at starting here, my sum is 0 and 0 is appearing one time. So I will store 0 in a map. So I will be using a map. Why map? Because in map we can store in almost amortized complexity, but we can say it is of one. So I will first store 0 and its frequency is 1. So in map I will be storing the sum and its frequency, how many times it has occurred. So I'll be, and here in this one I will be keep summing. So 1 came, 1, I will check, is it in my map? No. So I will store it in its frequency is 1. So again 1 plus minus 1, that is 0, and I will check, is 0 minus 3, is it in my map? So it would say no, it is not in my map. So I would, in like 0 minus 3 not in map means that There was never any situation x plus k minus, like there was never any situation where we got like x plus k we are at and we are searching for x, so there we didn't find any x, so nothing but 0 came one, so its frequency will be increased. Now I'm considering this part. Here we will get some idea like what this approach is doing. So we came 3, and here we will try to find in this map anytime did we find 3 minus k. K is 3. 3 minus 3 equals to 0. So we will try to find anytime wherever we have find 0. If that is possible, then we can, then definitely there would be some element whose sum is 3. So let's say I asked, is there anywhere we found 0? So we will see here we found 2 times. So in our answer, that would store our like count how many times it would be increased by 2. Why 2? If you see till this point the sum is what? 1 minus, it is also 3, and if you consider only these 3, that is also sum 3. So that is why our count would be increased, and 3 is coming first time. So 3 will be added in map. Now we will move ahead. 5. Now our sum is 5, and we will say 5 minus 3. Did we have 2 anywhere? So here there is no 2, so we will increase 5 as once. Now again we came here, 5 minus 1, that is 4. So we will see in our map like anywhere we got 4 minus 3. 1 anywhere? Yes, we found 1 once. So that can be our one solution. How? If you see from here till here, our sum should be 3. 1 minus 1 minus 2 minus 1 plus 2 0, and this 3. So that is a possible answer. So I will increase my count by 1. Why 1? Because 1's frequency was once. So I will increase my count 1. So now my count becomes 3. Now I will move ahead. This 5 comes 9. Like sum becomes 9. So we will see if there is no 9, we will add 9 ones, but we will check also like if there is 9 minus 3 or not. 9 minus 3 equals to 6. There is no 6, so no increase. Then we come to this 7, and 9 plus 7 16, and 16 minus 3, what is it? 16 minus 3, that is 13. So we will check is there any 13. So no 13, so nothing, and finally we will return our count. So this is going to be approach that we are using with map. I have already written the code. I will explain it also. So let me go to the code. So nothing much we are doing. We are creating a map. At the starting we decided we are putting map, we are initializing 0 1 because at the starting the sum is 0, and yeah, for a starting like it is coming once. So we are storing the sum 0 because let's say this was plus 1, and if this 3 will check in that map, so it would say now my sum, like sorry, let's not change it. Let's say this was 3. Okay, so it would check in map the like now my sum is 3, and it would check in my map that is there any 0. So if we don't insert a 0, that our approach will, like our solution will fail. So we are adding 0 at starting position. So that is why we have added map with 0. Now this is our prefix sum like till, and we are calculating, and this is our count. We will be storing the how many times this is occurring, and now I'm running a loop in this array. Every time my prefix sum will be like my sum, I'm adding the sum of that element, and in map I'm checking if that element is already there or not. So if my sum minus k is there in my map like this, so here my sum is 5, and I was searching for 5 minus 2, like if there is any 2 was there or not. If it is there, then that means was between them we had a k. So that same thing is happening here. If there is, we will increase our count with whatever the frequency we had. So like this here, we were checking 0, so 0 was 2 times, so we are increasing with 2, and at the end what this is what it is doing is, it is in checking and increasing the count. So if any sum, like let's say 9 is coming first time, so it will add 1 in front of 9 in map. But if 9 is coming second time, so what it will do is mp.get or default, first it will get 9 and 9's frequency, and we are increasing it plus 1. So this is what we are doing. At sum we are doing get or default. If it is there, it will get its value. If not, it will return 0, and then we are doing plus 1. Finally we are returning our count. So this will work. Now if we submit, the code is so small, but the intuition and logic is really good for this problem, and the thing was sliding window won't work for negative test cases. If you got the idea, you can like the video. Until then, keep coding.